Hey crew, welcome back to the next installment video in our basement bar build series. This one's going to be on the actual framing of the bar. This one's a little bit longer, it's going to be upwards of about 2 hours, but there's a lot of detail on this one I want to make sure you have because it is going to be one of the focal points of the project. As always, if you could hit those like and subscribe buttons, help me keep fresh content coming to you, and I hope you enjoy. We're at the point now in our project where things are really starting to take shape and we're ready to do the layout and the framing for the bar. So whenever you want to do something like this, where you're doing a custom built bar and you're going to do framing, you want to have a good representation of what it's going to look like when it's all said and done. One of the problems we ran into with this design concept is this support pillar right here. This is like right in the way of everywhere that we want to go. We've tried a couple different design options. I tried 45ing this before the pillar and moving it over. We tried stopping short right here, short of the pillar. Nothing's really working. So we came to the hard realization that we're going to have to incorporate this pillar as part of the design and work around it. Unfortunately, this is not something that I can just take the Sawzall to cut it out and yank it out. I could, but the house would collapse on top of me. So this has a lot of infrastructure to it. It's got a I-beam over it, and if you actually did a core drill below this, it's not just surface mounted onto the basement foundation floor. It actually goes very deep. There's what's called a footing underneath there, which goes deep below the soil. There's compacted gravel and all sorts of things on top of that to support the weight of the house. So if you run into something like this, please don't go thinking you can just take a Sawzall to it, move it over 4 feet, and do a surface mount and do another pillar. There's a lot of infrastructure and structural engineering that goes with this. So if this is in the way, you're just going to have to build around it, kind of like we did. If you really wanted that beam gone, there is the option to bring in a structural engineer. They can rework the plans of the house and do a plan to remove that pillar and put in what's called a header or a big beam that's supported on each side. In this case here, we talked about it with the customer, and the cost just didn't justify the means. It was just worth it to build the bar around it. It really was cost prohibitive to go through that process just for the bar. Again, I tried a few different options, nothing was really working. And in this case here, the cardboard really was our friend. If you're doing something like this, I strongly recommend doing a cardboard layout, just to give a visual representation of what things will look like. We do a lot of work with Generac home standby generators. We're a Generac dealer. And fortunately for this project, whenever a Generac is shipped, it's shipped with like a metric ton of cardboard that boxes in the entire pallet. So we got a lot to go around all the time. So we're able to do kind of a cardboard cutout for a template and get an idea how this is going to look. So we're able to kind of template out how we want our bar to look. And again, I tried a few different options, stopping short, doing an angle. And at the end of the day, as simple and basic as it seems, just doing right angle boxes around this pillar, looking at our cardboard cutout here, I think one, that's going to look the best. Two, it's also going to be the best for our bar seating spacing, right? At the end of the day, you're not going to be able to pack this in like it would be a local Irish pub, but we should be able to get a seat here, a seat and a half here, rather than just 45ing it off. I think doing this box around the pillar and then just doing kind of like a chamfer corner here, that's going to give us, one, the best visual representation of the bar. Two, it's going to give the best kind of comfortable seating around the bar. So we'll go ahead and we'll peel our cardboard up. I'll show you how I kind of did the template of the framing and the overhang of the bar and how I traced everything out, and we'll move forward with the bar framing. We have an idea of what we want the layout of our bar to look like and where we want the bar top to be shaped and move in the room. And to determine where we actually want to start our line, where we're going to actually do our framing, we have to make a bar template and take some measurements. This is actually a real life-size template of the width or the depth that the bar is going to be. There's a few measurements we have to take and trace out just to get a feel for some perception on what the bar top's going to look like and the dimensions it's going to be. If you go online and you do an internet search of bar top dimensions or standard bar top depths, you'll get a bunch of different articles and pictures and infographics of the dimensions that you need to have a decent bar top. This one is going to be right at exactly 20.5. That's going to be the real life depth of our bar top. So the reason we came up with those measurements is just making sure that we have enough dimensions for the different elements of our bar top. The first 8 to 9 inches, and again, if you do an internet search, it'll tell you what all these dimensions should be. The first 8 to 9 inches is the overhang of the bar. So if you picture you're sitting at a bar or table, you're not right up against the wall. There's a little bit of an overhang there that your legs fit under, that way your knees don't scrape the wall and all that. After we figured out that 8.5 inch measurement, we then measured back another 1.5 inches and drew another mark across our template. And that 1.5 inches is what's going to account for the 1/2 inch plywood, as well as about 1 inch of depth for the engineered stone that's going to be on the bar for the design. After that, we have to figure for our framing, right? We're going to frame this with 2x8s, and the actual width of those is 7 inches and a quarter. We measured on there, we measured back 7 and a quarter, and that leaves us with right about 3 inches, we'll give you that there for representation there, of what's called a toe kick. Because you're actually standing behind the bar. Again, on the bartender side, you want a little bit of an overhang too. That's where you're standing, up even with the bar, and your feet just have a little spot to rest. That's what's called a toe kick. You have the same thing on like your kitchen cabinets or your bathroom vanity. When you're there washing your hands, doing things, your feet actually recess under a little bit to get you right up to the counter. So that gives us right around 3.5 for a toe kick, which is exactly what we want. And that's how we came up with this template and that measurement for the bar. Once we have that, we put our template down and we figure out exactly where we want the end of our framing to be. I had our bar templated out, so I go ahead and I just put down this measurement guide. I measured back from the wall and figured out the measurement that I wanted to be away from the wall. Took my square, put it on this wall here, and I just traced my line out. Once I had my front line in, I then just went ahead and I did my side line at a right angle using my framing square. Again, just knowing that where the front edge of the framing is going to be right about 10 inches back from where that edge of the bar overhang is. Now that we have this all traced out on the ground, and again, you don't have to overthink it, right? Get your measurement, get a rough measurement. Give or take 1/4 of an inch, 1/2 of an inch, it's not going to make or break your design. You should have that wiggle room built in anyway, right? So figure out about where it's going to be. Go ahead and take your square, make sure the wall you're measuring off of is square, and then just do your lines. Here we'll go ahead and we'll get our framing members down. I'll go ahead and I'll mark those out. At this point in the video, I'm not sure if we discussed this yet or not, but a lot of my footage got corrupted that was on one of the portable hard drives where we talked about the framing. So I'm not sure if you have any education in this part of the video or not. When we put our framing members out, we'll go ahead and we'll measure those for 16-inch on-center framing. Again, same thing with the crowns. We talked about the crowns are always going to face to the back. That's going to be the same thing with the bar when we lay our framing out here, because the reason for that is if the crowns are curved, right, I can get one edge here and one edge here on my line and know that it's perfectly square. If I have my crown going the other way and I put the curved edge right here in the center, well, now I got to wiggle my board back and forth to make sure it's actually square and on the line where I want it to be. Whereas if I do the other ends, put the crown this way, I can hit end to end and we're good to go. So we'll get our boards down, we will measure 16 inches on center and move forward with the framing. Remember, even these stud boards here, even though they're short, they're only about 3 feet, we still want to do crowns up. I marked the crowns on each of these, and when I was cutting them down to size, what I did was I took the full 8-foot board, because it's easier to tell the crown in an 8-foot board versus a 3-foot, and then it's marked accordingly on the boards, just so I could see it when I was framing. Remember, when we're doing nails into framing, we want 1 nail for every 2 inches of dimensional lumber. So these are 2x8s, so we're going to do 4 nails across the board here. Couple things to just point out, probably covered these earlier in the video and other framing segments, but this bottom plate here, that is going to be ground contact pressure treated lumber, because it's going to be going on the raw concrete. Concrete has a level of moisture in it, it's always absorbing and getting rid of moisture, so we want to make sure that this is pressure treated to be able to withstand that. The other thing is, because we're using this pressure treated lumber, we have to make sure we're using galvanized nails. Something is going on with this stud right here. It must be a hard piece of wood or a knot in there or something. You can see a bunch of my nails are going up the side. I had a problem with two of them that I drove in. I'm just going to hand pound in some nails here, see if those hold, if those bust out the side of the board. I may just sister a new one in just for the strength, but we'll see how this goes. As we move on with our bar wall framing here, there are just a few extra steps I want to take to reinforce some of the framing. Talked earlier how I have this template that kind of mirrors the width of our bar, the depth of the bar. So we're going to have this overhang, right? And I'm not sure at this point in the video if I have completed the project, at what point I'm going to post these in series on YouTube, but if you've seen the finished project, if you see I plan on doing like an intro video showing the completed thing first, there's quite a bit of weight on this, and we also have the overhang. It's going to be a pretty thick epoxy casting with some cool stuff inside of it. So there's going to be a lot of weight on this overhang, and think of a lever. Think of like a claw hammer pulling out a nail with the lever where you're pulling. This is going to be mounted to the bar surface. Only a fraction of it is going to be actually screwed to the framing. So this is actually going to act like a lever, and it can tend to pull back. So what my concern is, and I love using framing nails, if you've heard me talking in the videos, 99 times out of 100, I really prefer nails and framing. We talk about the bar top in respect to it being attached to our framing here. We're going to have it screwed in really well along this framing member here, but we're going to have this overhang, and the pivot point, the halfway point, is going to be about right here, right? So what my concern is that over time, especially with people leaning on it, is going to have a tendency to act as like a lever, almost like a claw hammer pulling out a nail, and actually pull this top plate out and pull things forward, kind of like flipping it over like this. I don't think it would happen with the size nails that we have, the full-size framing nails, as well as the 4 of them in each one, coupled with just the way everything's going to right angle together. But I want to be sure, right? I don't want to call back a year later to hear that a 400-pound bar top fell on someone's legs. So what I'm going to do is use 2 different types of screws just on the far end to kind of eliminate that lever effect, right? Nails are really good for shear strength, but what I want is the threads on the screw engaging all the way down into our framing members to really hold that piece of wood, this top plate, and the bottom plate on, right? Because right now I'm mainly concerned about the top plate. I don't think we would have any forward rocking motion off the bottom plate because we're going to be secured into the wall there and secured into framing here, and everything's going to lock into place, but I really want to be sure. So I'm going to use 2 different types of screws for that. The first one, I'll see if I can get some close-ups of this. It's a construction lag screw. Whenever I'm talking about using screws in framing, I'm only talking about framing related screws, not sheetrock screws, not drywall screws. So if you look at this, it's a construction lag. These have a lot of shear strength to them, and it has a really big lag head on it, and it has a Torx bit, so you can really drill this down. I'm going to put that in about 2 inches from the edge. I'm just worried if I go any closer to that I actually might split the wood, because like I said, it's got this big honking head on it, and I got to really recess that down inside to make it flat for the bar top. And then I'm just going to use 2 more framing screws on each one, just to really lock everything in place. Is it overkill? Yes, but if you ever watch anything I build, it's usually overkill. And I also want some over-engineering here to make sure that this stays nice and stable for the lifetime of the bar. One of the things I did not talk about, I don't know if that's going to show on video, a lot of times traditional lag screws, I'd always want to go ahead and pre-drill those. These actually have like a little cutter head on the tip of the screw there, and it kind of cuts away the wood and almost does like its own little pilot hole. I am going to hold off on doing these screws on the very ends here, just because I'm going to be close to the end of the board, and even on this one I got a little bit of splitting on the end. I'm pretty confident if I put these that close to the edge of the board, it's just going to go ahead and split right through. I'll still use some of the framing screws, the construction screws. I'll probably just start them a little farther away and do them on an angle, just to make sure that I don't drive them too far. Remember, when you do this, when you flip it over, things are reversed, right? So that side we want the reinforcement screws in is on the other side. So if you saw in that last lag I tried to put in, it recessed about like a 1/16 of an inch, and then it just kept spinning, and it went ahead and stripped the threads right out. I had that happen to me on another board on the other side, but I was able to re-drill and countersink it enough. I suspect it's because this bottom plate is pressure treated, so the wood is less likely or has less properties to actually compress on itself like the non-pressure treated wood. So I don't want to keep running into that down the road, so I just have a small 1-inch Forstner bit. I'm just going to recess these, maybe about 1/8 of an inch, just enough to get that screw head recessed. Just be careful when you're doing this, because I have nails across here. If you're doing it, you'll have nails across here. You don't want to go ahead and nick one of those nails with the bit. One, it's a safety issue. Two, it's an expensive bit. So one of the reasons I really want to make sure I sink these screw heads below the top depth is this part's going to be on the ground, right? So we don't want the wall wobbling as we're trying to set it into the ground. So just a safety note here, you'll notice every time I'm using that drill with the Forstner bit, I'm taking my non-drilling hand or my support hand, and I'm overtly moving that to the back of the drill. That's two things. One, it does help guide it a little bit and keep things vertical, but it's also a safety thing to keep my other hand out of the way. In case that drill kicks, that Forstner bit has a lot of different cutter heads to them, and they're very sharp. So if that thing kicks and I lose control of it and it hits my other hand, it could be a really bad day. Just going to fire in a couple ram sets on each end just to keep it into place until we can tack on it. I have to redo that wall quick because the very last nail that I fired in when I just framed it went through a knot in the board that I didn't see on the other side and split the wood right down the middle. So stuff happens and we'll just redo it again. Fortunately, it's a short wall. At one point I did look up after the wood split. I made a funny joke, it's too bad you guys missed it. And I looked up and the camera was off. So I apologize for that. So I'm just going to redo this segment because I have no idea at what point the camera turned off. Alright, so again, don't know where I'm at in the video, don't know what was said or not said before the camera cut off last time. But as I was framing this wall last time, I was given what I thought was some good pieces of information. I looked up and at one point the camera was off. So I'm just going to reshoot it and I'll try and splice things in where appropriate. So before we get our nailing gun going, we're going to get our safety glasses on. If you look at the curve of this board, and same thing that I do when I'm talking about crowns, I'm going to exaggerate this. This board has a slight cup to it. And it's kind of going in that direction there, right? Again, I'm exaggerating that. Very common to see with pressure treated wood, just from the moisture and the chemical treating process and then the drying process. Sometimes you'll see a cup in there. So with this, it's important to make sure that cup, all right, that bow goes up, because it's very slight, right? If it was pronounced, I wouldn't use the board for this. But if we put it down, what can actually happen is the board can rock a little bit. If we put it the other way and we put the bow facing up, well, now we have a more stable platform, kind of the same way I talked about how I do crowns facing up on the studs. It just gives me a better nailing purpose. They're not rocking. Same concept here. We have the edges flat on the ground, so now when I tap con this in, it's really going to hold it tight to the floor. So as we go here, and again, I may have covered this earlier in this video or another one, but there's a large portion of the framing segment of this project that the data was corrupted on the portable hard drive I saved it to. I went to do some work and it just started beeping at me and I couldn't access my files. So it's currently at the manufacturer. They're going to try and do a data extract on it. So I know I covered this in that video, but we'll do it now because that might be lost. A little bit of a safety tip here. Whenever you're doing this first corner, sometimes they're very tricky to hold because you have this board going one way and the other board going the other way, so you have to hold them together and then make sure your ends are flush. When you're firing these nails in, you don't want your hand anywhere in the area of the length of the nail. I like to try and go at least double or triple that. Reason is if that nail hits a rough spot in the wood or hits a knot or something, it can fire out crazy different ways, right? It can go this way, that way. Usually it stops at the nail head, but it can pop out of the wood. So if I'm holding this here nice and flush, and I fire my nail in and it hits a knot, it can go right up through my hand, shatter bones, rip fingernails off, all that stuff. So we want to make sure that whenever we're firing nails, and this goes with anything, framing nailer, finish nailer, pin nailer for that matter too, I've seen it happen with pin nailers, you don't want your hands anywhere in the area in case that pops out. So that can be a little tricky with this first nail to go in because you're trying to hold everything together. So this hand here, we're going to take everything, line everything up. Now what we're going to do is we're going to hold pressure with our framing nailer, make sure it's on. We're going to hold pressure with our framing nailer. I'm going to roll this hand back and keep kind of pressing my arms in towards each other. Hold everything nice and tight, do one final check. Driver nail, we're all set. Remember, you're trigger disciplined, right? Anyone, cops or military out there, you're probably laughing right now. Finger off of the trigger until you're ready to fire that nail. So you see the Sawzall in there. What actually happened, I talked about hitting that knot in the board. That one actually had like a hard spot in the board, and when I fired the nail, it actually kicked that center stud over a little bit. So I just had to cut the nail out and redo it. Just wanted to illustrate, things happen, take a deep breath, and just calibrate how you're going to fix it and move forward. Now what I want to do really quick is just do a single screw into our OSB here, making this level. Just a quick terminology correction there, crew. Probably already getting made fun of in the comments for it, but I use the term level referring to the vertical up and down. The correct terminology for that is plumb. Plumb is what the term for vertical up and down. I said level by accident, my bad. So we'll make this part level, and then we'll level it to that edge, make everything nice and square and plumb and level and all that good stuff. One thing to keep in mind here, this is only OSB. I wasn't able to do this where it was on a stud cavity. I'm not going to rely only on the OSB to anchor this. Once we get this part of the project done, I'll go behind this wall here, I'll put some blocking in behind it, and then we'll screw that in and make it nice and solid. What I wanted to add to here quick is just this right angle piece. This side is going to butt up against that bar wall, so this way it gives me more anchor points to fire into the wall. We would do the same thing on just regular walls where we're doing sheetrock. If we weren't doubling up studs on the end and we needed a place to, one, to hit the walls together, but also for a purchase point for drywall for the screws, we would do the same thing, just do the 2x4 tube. I want to do really quick, I'm getting a little ahead of myself here. I wanted to save the Tapcons in the bottom for the very last. That way once I get the plywood bar top on, or the base, that's going to have a little bit of flex in it. I wanted those Tapcons to be the last thing I did, to really drive everything home and pull everything together. But because I have a little bit of that bow and that board on the bottom, what it's actually doing is it's pulling this front wall forward. You probably saw how I had to really wrestle this in to get it there. So what was level is now not, because that bottom board is kind of forcing the wall this way. So I'm just going to throw like a single Tapcon in there that should anchor that board flush to the floor, because that's what's happening. It's not fully square. The board is bowed and one end is bowed down farther than the other. So it's just rocking the wall forward a little bit. So I just want to get an anchor in the bottom, pull the wall back. I think, guys, we're talking like 1/8 of an inch here, not a whole lot. And that should be good to go, and we'll move on to the next step. While I was getting some tools set up there, I had to take the sweatshirt off. This upstate New York, the fall time, it's crazy, right? It's like 20 degrees in the morning and 60 degrees in the afternoon. Talked about how that the wall is kind of pulling forward because of that bottom board, and I want to get a Tapcon in there. I was thinking about it. Initially, my plan was to get the bar top on first, or not the bar top, but the substrate for the bar top, just the plywood. We're going to epoxy the bar top as we go here. But I just want to get 1 or 2 anchors into the bottom there. I'm actually just going to get all of my Tapcons in right now. We'll anchor that bottom in, and we'll adjust the top as we go. Usually I like to anchor the bottom last. I like to get everything set in just because it's easier to roll with everything. But I already got the tools set up now. Why do it twice? Hopefully you guys can see me peeking over the bar and all the setup here. Talk for a little bit, I'll go over everything. So as you see with the tools in front of me, there's a reason I'm just going to do all the anchors right now, because it's a little bit of a setup on the tools. In fairness, I do have 2 different drills here that I just want to show you the difference between the 2 and the power levels. So when we do the anchors, let's just go over the tools quick. First and foremost, we have our ear protection. I'm going to be reaching through the studs a lot here. And our dust mask, and a good N95. Once you breathe in that concrete, you can never really get that out of your lungs, so you want to stop that from getting in the first place, right? Always wear the mask. Much easier just to take a few extra seconds, be a little uncomfortable, keep yourself safe. One of the other things we're going to have here, we have our vacuum. Once we drill our holes, we just want to vacuum the dust out of there. Make sure we have a good clean hole for that anchor to make solid contact. A lot of times if you have little particles of dust in there, the anchor can actually bind up and you find yourself backing it out, blowing the dust out of the hole, and you've just kind of ruined your anchor, right? Because you ruined the integrity of the ridges on the screw. I used to be able to squeeze right through these things. So I'll just point out a couple of things in front of me. I have just my drill, my standard drill with a wooden drill bit. That's to get through the bottom plate. We're just going to drill through that just until I feel it kind of kiss the concrete, just till I feel it break through, and then we'll switch over to a hammer drill. See, I have my box of Tapcons there. We have a 3/8 inch by 3 inch screw. I probably could go 4, but I don't want to really drill too deep into the hole. My goal is really not to go through all the way through the basement floor. I just want to get part of the way through, just enough to sink my anchor in. If you drill all the way through the floor, not the end of the world, right? Because your anchor will be filling the hole. But underneath the foundation, you have water stop membranes and all that. When I say foundation, I mean the basement floor. So again, not a huge deal if you disturb that, because you're setting a concrete anchor into there. But the more I can keep that barrier intact, the more I like to do. See, I have my heavy duty impact there with a 14mm bit. That's for the, 14mm socket. That's for the hex head on our Tapcons. We got that box of Tapcons. A lot of times I'll use phrases that are like brand specific, and I'll mean something in general, right? Like I'll talk about sheetrock, and that means drywall in general. When I use the word Tapcons, I mean that brand name, Tapcons. I'm not sponsored by them. The Tapcons are just a good quality anchor. I find it holds really well, and they're rated for use in treated lumber. So it's weird, right? You would think something that's a concrete anchor would also be rated for treated lumber, but a lot of them are not. So I want to make sure I have a good anchor that's going to hold up both within the concrete and not rust away with my pressure treated lumber. I'm also going to have a 3/8 inch concrete bit for my hammer drills, for my rotary hammers. And I've got the 2 rotary hammers down there. I have the 12 volt version. The 12 volt is really good. I like it a lot, especially when I'm doing a lot of smaller anchors, especially when I'm working overhead or I'm working, I do it a lot when I'm doing generators outside for drilling into foundations for holding conduit and gas lines and stuff like that. So it's good when you're in tight spaces or you're crouching. It's just light when you're using smaller diameter anchors. That drill is rated for up to a 5/8 inch bit. It really struggles with it, right? You can do it. It's not really it's rated to do it, but it's not recommended to do that all day long with a 5/8 inch. So this is only 3/8. So you'll see the difference between that one, how it kind of bogs down with the bigger diameter bits. Again, it works, right? It does a good job with it. But I have the next size up. That's actually a couple sizes up in the Milwaukee hierarchy. That's capable of handling a lot bigger bits. That's capable of up to 1 1/8 inches. So you'll see how that powers through a lot quicker, a lot easier. And then I've got one size up from that. There's the SDS Max style. I also have a spline. I got a lot of hammer drills. I do a lot of drilling through concrete. The bigger ones, I really use those for the much bigger bits or using the core bits. When I have to get a 2.5, 3 inch hole through a foundation, that's where I'll use the bigger ones with the core bit. Went on a big dissertation on rotary hammers there. You'll see here that I start to set that tap time with my impact driver. So I get a little bit in and I back it out. That's because I've done a lot of these over the years and I can kind of tell when there's a little more dust in the hole than I want and I'm going to have some binding issues on the threads. So I felt that happening. It was before the point where I felt as though I would have ruined the threads. So I backed it out and made sure to get a really good vacuum and extract that dust in the hole. Just on the comparison of the 2 hammer drills there, you guys probably saw that. Both get the job done. The bigger drill though just gets it done a lot quicker, a lot easier. So again, if it was just like 1 or 2 holes, I'm probably just going to go for the smaller one because it's easier, right? It's a lot less tool to carry, especially if I'm working overhead or something. But if I'm doing something like this, a lot of holes down the line, I'm going to go for the bigger one all day long. What I'm doing here is I'm just measuring for a 45 cross member. That's both going to join those two bar wall sections together, as well as give another top plate just to support the substrate for the bar. It's actually a two-board concept here. The first one is going to go underneath, and it gets anchored underneath those existing top plates with construction anchors and some screws. And then the second one just matches the dimensions, and it just sits on top and sits flush with those other top plates. Yeah, so I just recorded the intro for this segment right here. The record button wasn't on and the camera shut off on me, and I was hitting it all like perfect. So we'll try and do that again. I don't know if I can do it. Crank it right along here. If you look behind me, you can see that our sheetrock taping has been done. It looks amazing. Our taper did a great job. If you're watching this, bud, thank you very much. Our next steps here are going to be to put the OSB plywood front on the bar on both our long side and our short side over here. And we're going to use 7/16 OSB plywood. As we talk about our OSB here and anchoring that on, we're going to use kind of like a triple threat, so to speak. First thing I'm going to do is I'm going to anchor that with nails. Remember, nails have really good shear strength, so as this board is pulling down, the nails are going to have good strength for that. I'm going to use screws to go ahead and anchor this into the framing and pull it in, so that if over time as things settle, the board is going to have a tendency to pull out. That won't happen. It can stay anchored in. And then I'm going to use this Liquid Nails construction adhesive to just kind of pull everything together and just give me one more thing in the equation to make a good strong bond. Remember, this plywood here is going to be the backing for our fake stone. And when I talk about the fake stone, nothing second rate about that. It's a really good product, and I've done comparisons side by side with that and real stone, and you really can't tell the difference. It's just much easier to apply than real stone. And if we ever do want to change anything for the future, it's much easier to pull that out than to demo the other stuff out. Talking about our OSB here, it's got a really rough side and a smoother side. We're going to want that rough side facing in. One is just for a better finished product on the outside. The other is the grooves on the rough side. That's going to give our Liquid Nails a little something more to bond to and create a little bit stronger bond. And then as we're putting this on, kind of very similar to drywall, right? We're going to go ahead and lift it about 3/4 of an inch off the floor. I've already got it cut to width. And we're just going to leave about 1/8 of an inch gap from the top, just to go ahead and leave for that expansion and contraction. Couple things really quick here. One, you might see the laser line on here for this, and I talked a little bit about this in the sheetrock segment. I'm actually going to use the laser line method for this, just because when I'm drywalling, I have that feedback of the screw gun to know if the screw went in or not. For the nail gun, I really don't. I mean, I do a little bit with the kickback, but this way I know exactly where my nails are going. I know they're going to be right in the center of the stud. Don't have to worry about missing. Not everybody necessarily has a battery-operated caulk gun. For most projects, you really don't need it. And actually, when I'm caulking trim for painting, I would prefer the old-school handheld one, just because it gives me that tactile feedback of the caulk. Things just go a lot easier. But when it comes to these thicker construction adhesives, I love this gun. All day long, I'll take this. Again, if you're just a DIYer doing caulk projects here and there, definitely don't need something like this. But if you're doing a lot more work using caulking type products, and you're doing a lot with the thick, heavy construction adhesives, this might be a worthwhile investment to you. And once you get the feel for it, you can almost kind of never go back. Leave a 1/8 inch gap between boards for expansion and contraction. Behind me, I have the OSB sheeting on the wall that initially when we put that into place, I just used the construction screws to get it up there and move on with the rest of the project. I have the framing nailer out and ready to go with the right size nails in there. So I'm just going to fire a few nails in each stud just to give it a little more reinforcement. So I am just going to stay away from this finished edge here and there, and I'll just start the next stud over and start my nails in there. Because this is finished, I don't want to go throwing nails into there and cause vibration and actually go ahead and ruin the finishing on that. Also, an errant nail could go out the side and ruin the finishing. That should be good for that. Just a few extra nails just to give it a little extra strength to it. I'm really not near as worried about the strength on that as I am about this, and even the front wall I'm really not worried about. But this is going to be a full stone facade on the front, whereas back here we're going to have the epoxy backsplash pieces all along here, and those will be resting on that back bar framing. There's just going to be a little bit of the brick facade up here, as well as shelves, so this doesn't need near the shear strength as this part does. Alright, time for a little bit of a science experiment and kind of a refresher from 8th grade physics, if I'm qualified as such to do that, which I'm not. So here we have a true 2-dimension from depth of our bar top. So by that I mean front of our bar top to the back of our bar top. This is exactly 20 inches. Now one of the things where I'm concerned about here is the strength of this bar top with the overhang. This is going to be an epoxy cast bar top. Casting epoxy has a lot of weight to it, especially the thicker you go, the more weight it's going to have. And in this case here, it's going to be about 1 inch to 1.5 inches of casting epoxy. That has a significant weight to it. I'm not concerned about the framing holding it. We sufficiently built that. We actually, as with everything, we overbuilt that. What I'm concerned about is the overhang here snapping under the weight of this epoxy. So essentially what we have here with our dimensions is about halfway through that is actually our fulcrum or our teeter point right here, okay? So as far as weight, we're going to have about half over onto the framing, the other half in front of the framing, so it's going to be about a 50-50 as far as the fulcrum here. So again, I'm really not too worried about that sliding off as long as our substrate can hold that and not snap. So you see right here, we're like right at that halfway point on our edge, and it's 50-50, just a little bit either way makes it go teeter off or teeter back. So here I just have a screw, I put that on the edge, we're good to go, all right? So I'm not really worried about the strength holding this on. What I'm worried about is this unsupported part without angle braces underneath not supporting this enough and having this part snap on me. We're going to do just a little bit of an experiment here just to make sure that we're good to go. I'm pretty confident with the strength of this 3/4 inch birch plywood, but I just want to double check before I go ahead and do everything. And there's a couple options we could go if this single layer wasn't enough, right? We could go ahead and we could double up our plywood, but the problem with that, and the reason why I don't want to do that in design, is because now we're going to have like a really thick bar top. Because it doesn't seem like a lot, but when you start adding 1/2 inch, 3/4 inch, you start running into that spot where you don't have enough leg room and your bar top is too low, or vice versa, right? You have too much leg room and your bar top is too high because we have such a thick space there between our substrate and then that about 1.5 inches of casting epoxy. So we really don't have a whole lot of room here. It's kind of like when you're doing cabinet making. Those little bits of a 1/16 of an inch add up over time. Same thing here. Every little bit does add up. So you have to put a lot into your planning process and try this out. So when we anchor this bar top on, I'm going to anchor it in with 2 types of screws. First one is just going to be our standard 1 5/8" construction screw. It's just going to go through and give me a little bit of hold in. And I'm not so much worried about the holding power going into the wood. What I'm worried about is the weight of all of this pulling the screw out. And again, I'm really not so much worried about that. I'm more worried about this snapping, but I do want to make sure that we have enough that's going to hold this on. So again, 2 types of screws. I have the construction screw, and I have this, what's called, it's a brand name, it's called a headlock screw. It's actually got a special proprietary bit design on there. We'll see if we can show you that. Bam. So if you look, it's not a Torx, it's called a headlock. It's a specific bit. It's like a different type of star pattern. So usually when you get a box of screws, it will include the bit. And then I also have just like a Milwaukee bit that I have bought in the set that actually has a headlock specific bit onto it. It has a very shallow head to it. So what that will allow me to do is kind of sink this in and compress these plywood fibers without having a whole lot of screws sticking up. Because once we start our epoxy casting on this, we really need this nice and level because the epoxy is self-leveling. So if my substrate isn't level, well, the epoxy is going to do the leveling job for me, and I'm going to have a bigger buildup on one end and a thinner buildup on the other. I don't want that. I expect like a 1/16 of an inch variation. There's, you know, Really no way to be perfect and get around that, but if I'm like at 1/8 of an inch or 1/2 of an inch, that becomes a problem and it just looks funky in the end. And now I'm here for 14 days trying to do flood coats of epoxy, trying to even that out. When you're sinking these screws in, I want you to think back about the drywall section. And if you didn't watch the drywall section, or if I know I'm in the midst of having a hard drive corrupted data issue, that's probably the 19th time I mentioned it in this segment. With sheetrock, I had talked about you just want to recess the screw just a tiny little bit below the depth of the drywall so it's smooth. You don't want to actually puncture the paper because then you lose your holding power. Well, the same thing on this plywood here. We just want to go through and take this and make it flush with the plywood. We don't even want to recess it below. I just want it flush because when I do my, the carbon fiber top on it and I do the epoxy, that will take care of all of that. I don't need it below flush. I just want it right with the top of the plywood. It'll compress those fibers down a little bit. The same thing with this headlock screw, and that's why I like it for this purpose, because it has a very shallow head, but it has a lot of holding power to it. So if we take it too far and we tear through those wood fibers, we lose a lot of holding power. It's not quite as dramatic as the drywall. With drywall, once you tear the paper, you're done. There's no holding power. It'll pull right off the wall. With the plywood, that's not necessarily the case, because if you look here, we have about 6 different layers of the different types of wood, and those are cross-stranded throughout. They're kind of, if you can see my Karate Kid motion here, you have the cross strands throughout, so you still have some holding power, but the less of that we can bust through, the better. The other thing I'll throw out there, and this is a little bit less true with plywood, a lot more true when you're talking, your hardwoods or actual stock wood, like your pine or your oak or your poplar, is you have the grain in the wood. And in this case here, the grain is going horizontal. Because of the sheets of plywood and how long I need the bar, there's no way to get around it with the horizontal grain not going this way. Plywood, again, it doesn't really matter too much because you have the cross strands underneath. It's still going to maintain my strength on me. If this was a hardwood style bar where I was doing like a slab of wood or something, unless it was like a live edge slab and I had no other option, kind of the same as the plywood. But if I was piecing together sheets of wood, I absolutely would not put the grain of the wood going the long way. I would flip that around so that they're going the short way of the bar for that strength. For my experiment here, I have this marked on the fulcrum point. And what I'm going to do is I'm going to take just one of these headlock screws and I'm going to put it towards the back of the framing on the bar. Remember we talked about that fulcrum, right? Again, going back to like that 8th grade, physics, what was it? Physical science, I think it was called. Going back to that physical science from middle school, high school stuff. Remember, the closer to your fulcrum or your pivot point, the more force you have to apply to get the object to go the other way on the pivot point. But the farther away you go, the less force you have to apply. I'm barely touching this at the end. So I'm going to want my screws zigzagged all over, but especially the headlock screws, I'm really going to want to focus on putting those as far back as I can, again, because of that pivot point or that fulcrum point. The farther back I put those screws, the more strength I have on this board rocking. Here we are. This feels pretty solid, and that's just one headlock screw in there. Realistically, if this were the real life dimensions of the bar, I'd probably have, just spacing it out. In this distance, I'd probably have about 2 headlock screws. My goal would be to get one kind of the area of every stud. So I'd have one about every 16 inches. And I'd probably have 5 or 6 of these construction screws zigzagged around in here to hold everything on. Feels pretty strong. Let's test that out. Here is my demo bar top that I made. When I was talking to the customer, we were talking about like the design concepts for the bar, about what they wanted. I thought this was going to look really, really cool. So I had made this just as like almost like a proof of concept type thing. Before we kind of build things around this concept, let's make sure everybody likes it and it's going to look good. So here we are. This is about real life how this would be. We're short a couple of inches. We're about halfway, and there's no problem with that kind of T-drain. So what I'm actually, and this is actually a little bit wider. The actual bar top is about 20 inches in depth from front to back. This concept is about 24 inches. So maybe we can smooth this forward a little bit. Still nothing, right? We're good. We're good. It's gonna snap it. Let's move this all the way to the edge. I think we're gonna be good, right? This is more than double the weight what would actually be on here, right? Because I have a wider demo bar top that's pretty much, you know, the same depth as this is gonna be. And it's not even spread out anywhere. The entire weight of this is all the way on the end. And that's just held in with one headlock screw, right? That's just one. We're gonna have a lot more in on here. I wanna do one more thing to make sure this is gonna be good. I have not demoed this. I have not tried this yet. I'm doing this real life, real time. I'm pretty confident in my construction abilities and that this is gonna hold. Keep watching. You might be in for a good show right here. If you work for OSHA, do me a solid, hit a couple skips on there. Maybe go 2 minutes forward and maybe just forget about this part, okay? Bam. Give it a few bounces. We're good to go, guys. I feel comfortable up here. There is, not to mock myself here, but to mock myself, there is a considerable amount of weight on this board that's just being held in by one headlock screw as I'm up here talking to you, right? And like, I'm not even nervous, I'm not holding on. That was to start, right? But right now that I'm sitting on this feels nice and solid. Again, there's a disproportionate amount of weight, exponentially more weight that's hanging on this right now than what really will be in the finished product, right? I mean, part of that's because I really haven't been living a healthy lifestyle. When I leave my work job every day, I go home and I drink beer and eat chicken wings instead of, you know, eating chicken and hitting the treadmill like I should. I'm working on it, right? So we're good, right? That's just one little segment held in by one screw with a ton more weight on it, maybe not a literal ton, I don't want to go that harsh on myself, but a significant more amount of weight on it than the actual bar top's going to have. So by the time we have a whole bar top here, and by the time we have a whole span of screws, I'm 100% confident in this. This is going to be 100% fine. If this was wagging a little bit as I'm bouncing up and down, if I could hear it cracking a little bit, which I don't, I would just go ahead and I would just put some angle braces in as we go, you know, kind of like you see on granite countertops a lot, just angle irons that will go like this underneath and support it. The reason I don't want to do that if I don't have to is it's just aesthetics and it's, what's the word I'm looking for, not comfort, ergonomics. It's ergonomics of the bar, right? Here, if it's a fully open space underneath, people can move around as they want, you know, people can space out, whereas if you put those angle iron supports in there, well, now you're limited to that space between the angle irons. So we'll move forward, we'll get the bar top on, I'll show you how I'm going to anchor that, and see you in a minute. One more quick thing and then I'm done talking about this whole fulcrum pivot point support thing, I promise. Again, as we're talking the amount of weight that's going to be on here, I think we've clearly established at this point that the construction is going to be able to hold everything. But remember, when we do our casting epoxy, the unsupported weight on this side, just this end has to support to the extreme, is going to be very short-lived. It's not going to be the life of the bar. When we pour that casting epoxy in this entire large mold here, over time, as that epoxy cures, it's going to become all one piece, kind of like all one big piece of plastic, so to speak. That's essentially what epoxy becomes. Once it hardens and once it cures, it's like a big clear piece of plastic, very, very hard acrylic plastic. So once all of that happens, this section here that's over this unsupported part is going to be kind of fused with this section here. So it does kind of all become one, and all we have to do is make sure it's anchored here so it doesn't flip off. If that happens, I'm really not too concerned with this unsupported section here. It's just a matter of getting it to that point. Yes, of course, there is always, you know, the part where, oh, someone's going to be leaning on the bar, they're going to be holding their hands on there, there's going to be drinks, there's going to be food. I think we have well established with me sitting on this thing, again, significantly exceeding any portion of weight that's going to be per square inch on this, that our design is solid and we're going to be good to go. As you can tell with this entire video so far, I have a strong tendency to overbuild things and future-proof things so that there are rarely issues, especially issues that I can foresee. So if there was a doubt in my mind that I thought this wouldn't be strong enough, I would either do a redesign concept and double up the substrate here for a double panel, or I would go for those angle support braces underneath. Onto the bar. Next up, I'll go ahead and we'll start mounting the bar top, and we'll show you how we're going to glue that on and anchor it in with the screws and all that, and how we designed our split to be the strongest part, because plywood only comes in sheets of about 8 feet. Happy with the way that turned out. You probably saw me fiddling over there with the shims. I had a little bit of leveling to do over here. I'm going to have a little bit of leveling here just to make sure it's level on this axis here. Perfectly normal, right? If you ever pull off like a little kitchen countertop or something, you'll see there's always shims in there along the way. During the framing process, you can only get that so level, right? There's always little imperfections in the lumber that you're using for the framing, as well as around the basement floor right here, right? So in a perfect world, everything would be level, but concrete basement floors are never like that, right? They're kind of, I'm exaggerating this here, but you'll see that most basement floors are kind of sloped like that. They taper off on the edges to channel water away into a French drain or into a sump pump. So we get it as level as we can, and then what we do is we just use the shims to go ahead and get it the rest of the way. It's pretty crucial here that I get this as level as possible, because again, it's going to be that epoxy bar top, and we're going to flood coat the top of that with epoxy. So even just like an 1/8 of an inch variance, that can have me do a lot more flood coats. If I'm shallower over here, I can have to be doing a lot more to build that up and to make it level. As we progress here, when we tack this down, I already kind of showed you the screw concept and the specialty headlock screws I'm going to use. And we're going to use that really good Liquid Nails construction adhesive. We'll get a really good bead there. We'll really build it up down along this edge here, because I know I got some leveling here and some void spaces. So I want to fill that with the construction adhesive. I want to make sure I have solid backing and solid bonding under here. One thing I'm going to do before I do that is I am just going to take these screws out. I got a pretty good guide of where I want to be. And then before I start again, I'll just kind of line up the screw holes. That's one of the reasons I did that. Before we actually unfasten this, get the caulk down and do our final anchoring on here, is I am just going to take my router and I'm just going to do a small round over on the perimeter of the bar. And then when I get to this end here, I'll just unfasten it and zip that end. And that's kind of important, because what I want is a slight round over on this. And that way when I do the carbon fiber fabric over the edge, it'll lay over that curve, so one, it'll help with that process a little bit, just kind of embedding that in there. The other reason is when I do these wooden surround boards that are kind of going to be the perimeter of the casting, and I cut the rabbet in those, and you'll see what all that is when we get there, this round over here will actually give me kind of like a channel for the glue buildup or the construction adhesive buildup. So when I press my board on there, I'll have a little reservoir, and that can seal. So now when I pour my epoxy in, it won't leak out the edges. At least we hope it's not going to leak out the edges, and there's one more step I'll take to make sure that doesn't happen. We're about to go ahead and do our round over on the edges of the bar top here. I have my router set up with a 1/8 inch round over bit. Don't need anything extreme there with the radius, just a very small curve, very small round over, just to let that fabric lay over, and then also create that kind of channel for the glue to actually rest in and create a seal so the epoxy doesn't leak out. I'm going to show you something else we do when we get to that step to kind of increase our chances of not having a leak and keeping the epoxy in the casting area. A couple safety things before we do this. First and foremost, as always, safety glasses. Whenever we're using wood cutting tools, we always want the safety glasses, especially the router. That tends to throw off a lot of wood chips, and then couple that with the plywood. Plywood throws off a lot more wood chunks than your solid hardwood or your pine does, just with the nature of the plywood. It tends to throw off wood chips instead of sawdust. So make sure you're wearing eye protection. You want to make sure there's nothing that can actually get sucked into your blade and suck you in. That's also why we don't wear gloves when we use power tools like this, because what can actually happen is if it catches the skin, okay, you've cut your skin and you pull away. If it catches a glove or something, and not so much talking about the router, a little bit the router, but like when you're talking your benchtop tools like a table saw or a joiner, it will actually suck the glove in and keep sucking while it's cutting away at your finger, cutting your fingers off. So
Don't wear gloves with power tools. I think we got that.
I did misspeak a little bit there, and I just want to clarify. I used the phrase, don't use gloves with power tools. Not necessarily true, right? There are often times where you will use gloves with power tools. I do it all the time, right? Using the drill, using the Sawzall, doing demo work, that's all well and good, right? Just make sure you're being safe and following the manufacturer guidelines. More so what I was referring to is when you're doing the rotary tools, right? Like the router, the joiner, the table saw, the miter saw, those types of things. Things where your hands are just unfortunately inherently close to the blade, it can get sucked in. Those are the applications where you don't want to wear the gloves, because if your glove catches, that's when it just kind of sucks your hand and your arm in, and it just keeps pulling in and pulls on the leather or the fabric of the glove and keeps cutting away at your flesh and your bone.
That segment was going great until the generator did its self-test and threw me off my game. But it's a generator that I have for a service contract and I do the work on it, so I am happy that it started up and it sounds like it's working awesome. Alright, back to business. So if you notice right now I'm wearing a hoodie. I tend to wear hoodies a lot when I work. It's just kind of my wardrobe and what I find I like to wear when I'm doing construction jobs, right? Especially in upstate New York, there's a lot of temperature changes. It's 68, 70 where I'm working right now, but then I'm going to be going up into the garage and up into my work area to be cutting wood for framing in about 20, 30 minutes. So I just find the hoodies work good for that, right? They're not too hot, they're not too warm. I can roll the sleeves up if I start to get hot, and they're baggy enough, they're easy to bring on and off. Enough of the sales pitch for the hoodies. What you may or may not notice with the hoodie is I don't have the drawstrings in here. And that's kind of what we talked about earlier with not having looser baggy clothing or things that can suck into the power tools. So whenever I get a hoodie, I always go ahead and I pull those drawstrings out. It's the first thing I do. I snip them, I cut them. I don't ever want those hanging down. It's one of the things where if I see one of my workers on a job site with drawstrings, I'll tell them once, get rid of them. If I see them again, they're going home for the day. It's that much of a safety issue. You may not notice it, you may be like, oh, I'm fine, I'll see it, but you get down and you start doing some work, you get a little close, next thing you know, those dangle in and they get caught in your tool, and that's a real bad day. You know, like that's potentially like ripping your face off or, you know, a saw blade through your head fatality. It's just a nightmare. Doing work like this, or if you know, doing some DIY stuff, focus on safety, especially when you're talking power tools, right? You really can't be safe enough. Power tools are exactly that. They have a lot of power, and accidents happen real quick, and before you know it, you are into something life-altering and catastrophic. I'm not trying to fear-monger here, I'm just saying, respect the tools, think of safety. It's easy when you get going into a project to just think about doing the work. On the forefront of every step when you're using power tools, it should be, are we being safe? What can I do to improve my safety? What safety steps am I missing? Enough of that, let's get into the router. I have a few screws just holding this on, holding it in place still from when I mocked it up. I'm going to do most of the routering with this held in place, but there's going to be a few areas I'm not going to be able to get, right? I'm not going to be able to get in around this pole, and I'm not going to be able to get the edges to the wall. So what I'll do is I'll get most of the profile done, because I have the screws holding it in, and then when I get to those spots that I can't get with it being screwed in, I'll just unscrew the board, hold it down, and router the edges. When I open up my tip here, I'm going to open that pretty wide, all right? On this back edge here, I'm going to want a really wide bead of caulk. Remember we talked in that segment ago where I talked about the balance of the board and the fulcrum points and all that stuff. So where I really want the strongest hold is this back edge of the counter, because that's where all the pressure is going to be and that's where the most force is going to be to hold this down, right? So I'm going to put a nice wide bead on the back here. So I opened up the tip nice and wide, and then I'll do some zigzags back and forth just for some extra holding power. Those will be a little bit smaller. So I've got the wide opening, I can always just bring the caulk gun faster to reduce the size of that bead. Always have a second one of these on hand just in case you run out. The other thing I'll talk about, and the reason I want the nice wide bead, is we're going to have some leveling to do, right? A little bit on the long side, but we're going to have some tweaks back and forth, and I'm going to have to throw some shims in. So kind of the same thing with tile, where you want a nice wide ridge in there to allow for that leveling. Same concept here. We're going to kind of get this set on. I'm going to throw a few screws in, and then we're going to tweak it with the level. So if I have a small bead on here, yeah, a small bead will hold, but now if I go to lift up a little bit, I want some residual glue in there to still hold together. I know you're a little bit out of frame over here, but over on this edge of the bar, the framing is about just a 1/16 of an inch lower because of where the floor starts to dip down. So I am just going to put a little more glue build up there because I do know I'm going to have a lot more shims to put in there from the mock-up. As you can see, when we do the heavy beads like that, 1 tube really doesn't get you a whole lot. So I always recommend having a second one on tap, just in case you run out. It can be very deceiving how much is, or how little rather, is actually in one of these when you're doing a large bead. Just gonna throw a little more on here. Now is the time to do it. Like we said, we're gonna have a lot of weight on here. The more fastening capability and the more adhesion capability we have here, the better. I'd rather spend a couple extra bucks and a little extra caulk, have some squeeze out I gotta clean up, than wish I would have put more down. What I've done here was I took the screws that I used for mock-up and I just drilled them through a little bit extra so I can just kind of line up the screw holes, get this into place, then I'll back them down, level everything out and tack them in. I'll just scrape my glue there. Time is a little bit of the essence here. It's not, it's not certain epoxies where you're getting down, you got about 2 minutes to work, but we don't want to dawdle on this stuff. It is out of the tube. As soon as it does hit the air, it does start to cure. So we want to get this down and set as soon as we can. Screws and I drilled them in a little deeper so they almost kind of act like little spikes or cleats or feet so that I can see where the board is lining up with the old screw holes before I actually set this down into the glue. That way I don't have a whole lot of lift off of the glue if I have to pull the panel back off. One of the things I do wish I would have done, which it's not a big deal, I'm going to figure it out, right? It won't be that hard, but I do have a couple different sets of screw holes from when I was mocking this up, trying to get it flush and even with this one as well as do the leveling on it. So I have a couple different screw holes that aren't going to be used, and I'm like, crap, is that the final screw hole version or is that the first version? So I wish I would have just taken a pencil or a marker and just drawn an X next to the screw holes I wanted, so it's easier to line these little cleats up, but no big deal, we're going to figure it out. What I'm doing here is I'm just marking the location for where I want to drill in those headlock screws. Those are the ones that have that kind of wide flange body on them that are really going to give some good holding force down. So I know that my framing starts at the 3-inch overhang, right? I have a 3-inch overhang on this side of the bar. So roughly going 3 inches in from the edge of the bar, that's going to get me to the edge of my stud. So what I'm doing is I'm marking 4 inches in. That gives me about 1 inch of stud space to work with. And I'll zigzag those a little bit, right? Some I might do it 4, 4.5, 5. I'll weave them on down just to give different levels of pressure. But I know that that's going to be a safe spot where I can get that screw into enough framing. And I'm lining it up even with the stud. I'm getting even with it and then drawing my line down so that the screw can go through the bar top, through our top plate on the framing and then into that stud. And I'll do a couple more that just go into the stud, or I'm sorry, just go into the top plate as well to really hold them down. But I want to have a couple heavy anchors that really go down into the stud. And if you remember when we did the framing, we did some of those in the framing too. So a lot of this might be superfluous, but overbuild it, right? We're going to have a lot of weight on top of here. What I did there is I described a rough line at about 5.5 inches. I have about a 4.5 inch overhang on this 45 out section of the bar. We have a little bit of extra space here, but I have that diagonal cross member framing that runs underneath here, and that's going to be a huge structural element for this entire portion of the bar. That actually gives us a lot of structural integrity, kind of having that on there. We don't really have to worry about that whole fulcrum thing on this end because we have so much surface area. But I have a good set of double stacked 2x8s under there, so I really want to use those lag screws and drill in and capitalize on that extra framing here. I kind of got my screws spaced out. I got them staggered. Longer the screw, the better. You also want to be careful not to overdrive too, right? You drill so many screws into the top of the stud before you start to chip away the wood. Remember, we already have some screws that are kind of spaced in there. So I think we have a good mix here. Remember, they have kind of that shallow flange. That's why I like them for this. We just want to sink them flush to the surface of the plywood and no deeper, just like the drywall. One thing I forgot is these headlock screws do have their own bit design. So make sure that you have a bit that's capable of doing that. Sometimes the packages come with them. Actually, usually they do. Just if you're buying them and you plan on using this style screw, this goes for any style construction lag because they're coming out with all different kinds now. Make sure that either you have the right kind of bit for it or that it's included in the box. Usually they are, but like with these ones here, they weren't. So just make sure you have it. So one thing I forgot to mention when we were done doing the leveling process, because I was so excited to move on to the next step here, we're mostly level, right? I'm 99.9% level. When you're talking a situation such as this, I have two different types of framing that come together at a right angle. I have two different pieces for a bar top or a countertop, and I'm on a basement floor that's wavy like the ocean. It's darn near impossible to get all that at 0.00 level, right? I'm at about 0.1 or 0.005, yeah, on both of these. We're off by just a tiny, tiny bit. Again, not even gonna be noticeable to ever by a human element if I didn't say this on camera, right? If we poured a drop of water here, it's not gonna go anywhere, it's gonna stay still. If I put my pencil down, it's not gonna move anywhere, we're good to go. When we get to the epoxy though, that's going to make everything the be all end all, make this 100%, 0.00 all the way down the line level, because the epoxy is self-leveling. So when I do the casting epoxy, that's going to take care of everything in self-level. And then when I do my flood coats on the bar top, that's also self-leveling. Now if I'm off by just a little bit on that end to this end, that's where the self-leveling is going to come into play. I might have to do 1 or 2 extra flood coats, put it on and let it level out and keep cleaning up the drips, but that will make everything absolutely perfect. If this was something, say like a granite countertop, we wouldn't worry about any of that. I have a bunch of pieces coming together here, so I'm trying to make them all level. If it was like a granite countertop or a laminated MDF countertop, well, you just take that from the ends and you make the ends level, and then you shim the middle where the gaps are. So that's how we would be doing this if we had a solid countertop, but because we have that epoxy that's going to self-level, I went from one end and just worked my way to the other, making sure we were level as we went. The next step here is just to do a pocket hole screw. Now do the same thing on the other side, and that's just going to hold these two pieces flush. It doesn't have to be anything serious. If it did, I would glue it and use biscuits or a dowel, but it just has to be enough to hold these two pieces flush and even with each other until we do the epoxy. And then when we get the epoxy in, that will seal it all together. Alright crew, one last step I want to take before I break for lunch, because I want this dry after I get back from lunch, because I'm going to do some painting after that, is I want to go ahead and I want to just take this is a good caulk, Dynaflex Ultra. It's got a lot of elasticity to it. I just want to take that and I want to seal my joints horizontally and vertically in my OSB here. It doesn't have to be perfect, because this is all going to be like a stone facade or a backsplash. You really won't see most of this. But what I want to do is I want to get a coat of paint on just this lower portion so that I can put the framing in, and I'll talk about that when I get there and why I'm painting it before I put the framing in. But I'm going to go to lunch. My next step is actually getting some primer and some paint on this before I frame it in. So I'm just going to go ahead and seal these so that we can prime and paint over those later. It'll make sense when I get there. In the previous segment, I think I talked about liking my, some applications I like the hand-powered caulk gun. Other ones I like the battery-powered one. So this is one of those situations where I'm caulking seams where I like the hand caulk one. Usually when I'm doing seams like this or when I'm doing trim. Because one, I can control it a lot better and a lot easier. The other is I almost kind of get like a tactile feedback. I can feel where the glue or the caulk is actually feeding its way into the crevice. And this doesn't have to be exact. This is just kind of filling the gap here, so we can get a smooth backing for our paint here. Doesn't even need to be smooth, just so that we don't have a crevice when we do our paint. And 95% of this is not even going to show. It's all going to be covered by either the stone facade or back bar or the backsplash. I'm making this probably much neater than I need to. I'm just trying to fill this crevice so that when we paint over it, it's all one color. It doesn't need to be like wall smooth, just enough to fill the gap so we don't see the air coming through. One of the next steps we're going to have here is to do the framing for our back bar, get that all anchored and then get the top on that. Before we get into anchoring our framing and getting all that done, we have to think a little bit about the design concept of what the back wall is going to look like. So the countertop and below is more than likely going to be an open concept design with just black paint on it. And then up top is going to be a combination of our epoxy backsplash accent piece as well as the stone facade, that fake stone facade we were talking about. So the point I'm getting at here is the background here is going to be black. For everything else, we're going to hit it with primer and then 2 coats of black paint. The problem with this and putting the framing in before is we talked in a couple previous segments and other videos about how wood can expand and contract. So what my worry is we're going to get everything in, I'm going to spray prime everything, and then we'll spray paint everything. We'll do all that more than likely with our airless sprayer. But what can actually happen is it looks all nice and good from the start, right? But after a couple seasons of expansion and contraction, what will actually happen is if we leave parts of this unpainted beforehand, little parts of raw plywood will show through if we keep that open concept design. We might do a face frame on there, we're not entirely sure yet. But if we keep that open concept design and we start to have changes of the wood expansion in the seasons, you might just get little slivers of the raw plywood showing through, and that's going to look horrible. So what we're going to do is before we put the framing in, we're just going to go ahead and prime this and then get 2 coats of black paint on here so we never have to worry about that, right? Even if we have some expansion and contraction, it's all going to be the same background black color. Our back bar is going to go up to about here. It's going to be about 3 feet high, so we're just going to go ahead and just paint right over this line, this way we know we're good. And this doesn't have to be anything pretty. We're just hitting some primer on this, and then we'll hit it with some black paint. A couple quick tidbits as I'm going along here. As we're rolling, you notice I'm doing it pretty crude, right? Especially when I'm putting on that first coat. So get the first coat on there, just get a base layer going, and then I'm taking just a little extra paint on the roller, working from one way to the other, and smoothing it out in a end pattern. Talking about getting into the edges here. I'm getting close enough into the edges. If this was a finished wall, I would take a paintbrush and then, get as close as I could with the roller and make it nice and neat. But most of this is going to be covered by our framing, so those little parts that I'm not getting are not going to show, and the wood is never going to expand and contract enough, unless it defies the laws of physics, to actually expand far enough where we're going to see that raw plywood. So having this little bit of raw open edge in the corner is going to be fine, especially with the design of the bar. This is going to be the back end of the framing. We're not going to see that. And then up here where it's open on top of the back bar, there's going to be enough infrastructure up there. We're never going to go ahead and actually see the plywood if it does expand and contract, a little bit. Hey crew, back, sorry about that. You can see we had some off-camera work. I was in the middle of a sentence, I was making a great point, and the camera ran out of memory, and I was already mid-painting and priming, so I just finished up this section. I'll just kind of start from the top on the last one because I don't quite remember exactly what I got out when I did it. So one of the things I wanted to point out was I'm using a dedicated primer on this, right? And I'm sure there's going to be haters going, they make paint and primer in one. Yeah, I'm well aware of that. I use that product all the time, and that's actually what we're going to put on next. But one of the things we have here is I really want good adherence to this wall, right? And you can see from the difference of when it was going on wet versus now, that first coat of paint really sucks in. So that paint and primer in one is a good product, but it's only about 5 to 10% primer depending on the product you're using. So I want to make sure I have a dedicated primer on here to really prep the surface of the wood and make sure I have good adhesion on my top color coat. So whenever I can do it, whenever I'm doing a project, if I can actually do a dedicated primer, I will always do that. It just preps the surface better, it soaks in better, and it just creates better adhesion for that final top coat, or final two top coats. Usually I do two, especially here, because we have a white primer with a black top coat. We could get away with a tinted primer that's just not, if I just used a little bit out of a can, right? I just have gallons upon gallons of just plain white primer that I use on all my projects. If I was doing the right application, if I needed a lot of it, I would get a tinted primer and you could just tint that black and get away with just one top coat. But in this case here, the couple square feet that I have, the cost just doesn't justify it. One of the other things I wanted to get out was we're priming, we're doing wet paint on OSB, right? So if you're using like raw wood or drywall, you can a lot of times go a little heavier on your coats. With this OSB, it's going to be real susceptible to bubbling a little bit on this top strand layer. Remember, the plywood just has all these shards and they're crisscrossed all over the place. So if you go too heavy on your paint, you'll actually get some bubbling in your layer on the plywood here. Not a big deal. Again, we're kind of going for a crude industrial look here anyway, but just keep in mind when you have this, just go light and go really light and do more coats as opposed to a heavy coat. If I had my preference in a perfect world, the actual product I would use here for the sheeting behind would be the Advantech brand. That has a protective layer over the top to help seal it from the elements, and that would take the paint a lot better. It would be less prone to the whole bubbling aspect, but we are, as always, in a supply chain shortage, and this regular OSB is a lot easier to come by than the Advantech. It's also a lot more cost effective in this application too, so we're going with the OSB, no big deal. We have a coat of primer on, and you guys saw how I did that. Just rolled it on nice and rough, and then I just dipped my roller in again and just in an end pattern, even that out. Don't have to be perfect, right? We're just trying to prep the surface. Most of this is going to be covered anyway. And again, the reason that we're prepping this right now with the black paint is to make sure that we just don't have any little pieces of raw plywood showing down the road when we have our expansion and contraction. We're just trying to get that base layer on the back. Once I get the framing in here, and once we get the paint, I'm going to go over everything else that's raw wood anyway. And it's all going to be like a second or third coat. So just need a little bit of a background here. We don't have to go crazy. Now what I have is my paint and primer in one, and you'll see how much easier this goes on with the primed wall. All right. So this is why I like doing that dedicated primer first. I may even, I'll probably still do two coats because remember, like I said, you want to go light. Just because you have that primer on doesn't mean we're not going to get a bubbling effect. You'd rather be safe and just do 2 coats. Yeah, you see how much better this rolls out when you have your dedicated primer base on it? I mean, granted, it was a well-saturated roller, but I'm already halfway through on this wall, and I still haven't had to redid my roller. With the primer, I think I was at probably, what, 5 or 6 dips at this point on the roller. Oh, and the paint over here is going to kind of even this out so we don't get that bubbling effect I was talking about. Went a little heavy on that first one. So the product I'm using here is it's just a standard paint and primer in one. Doesn't have to be anything high grade. Doesn't have to be anything high grade. To be honest with you, just whatever the cheapest they're going to offer at the store is going to be fine. Again, we're just trying to get that background color on here, and just a matte black product. Just a flat black, straight black paint. Look at that, we're able to get our first coat on this back wall with one trip of the roller here. Just trying to get that caulk line while my roller's still nice and wet here. Just to show you the difference on the unprimed wood versus the primed one. That's the coverage there with the freshly dipped roller. You can just see how much better a primed surface takes that top coat of paint versus an unprimed raw OSB surface. It may not be showing on camera, but this layer here is nice and smooth. And this one here, which was a fresh dipped roller, there's paint on there, but the coverage kind of sucks, and there's all sorts of imperfections and just bad coverage. When this dries, hopefully the camera will actually show just the difference of a top coat with the primer versus top coat, no primer on those 2 spots up there. Give that a little bit to dry, we'll hit it with another coat, move on. Alright, so we have that area prepped and painted. Just a quick example behind me, you can see on both sides here, those are 2 top coats of just flat black paint and the primer that went underneath to prep the surface. So just a comparison here, if you saw while I was rolling this out, may or may not, and we'll see if I cut it out or not. But I have my surface down here that was primed, and then up here behind me, I just have 2 spots where I was doing the top coat of black paint. I just did a few rolls of like what would be a top coat up here without primer. So you can see the difference, right? It coats, it holds. Down here just looks like a much better finish. And even up here, after 2 coats, we'd probably still need a third to get the same coverage that we had down here. And the camera's probably not showing it, but just the surface here that was primed first just looks like a much nicer finish. One extra step you may have seen me take there during my layout that you may not have seen before is I actually marked the inside face of the board. So normally when I do my layout, my marking for the framing, I'm just doing the edges of the board, right? And I'm marking the edges where the stud should be, drawing my lines, drawing my X for the middle, and just going from there. And then when I'm doing my framing, I'm just lining everything up on the board, making sure it looks as straight as I can get it, and then nailing it. There's a possibility when I'm doing that, my only reference point is going to be the edge of the board, that board could be tweaked 1 or 2 degrees. If I'm doing a finished wall with drywall, don't really care, right? Because it's going to get finished with drywall, it's within tolerance, no one's ever going to see it, and it's probably straight anyway. If the design as it stands now, the framing in the back bar is going to be open and just painted black. That might change as we progress, but right now that's how it's going to be. So that's going to be more of a focal point, and people are going to see those studs. So what I did was I just continued my layout lines down the board with the square. I marched out where I did it on the edge of the board, and I just took them all down the face of the board. That way when I'm doing my framing, it gives me one more reference point to make sure they're as square as possible.
next here is I'm just going to put some pieces of blocking in on the framing on the back side. This will be the side that's against the wall. That way when we get this set up, we'll anchor in the bottom with our concrete anchors, and then we can use this blocking in the back to anchor to the studs already in the wall, make this a nice solid platform. One thing I will caution you on, we did all this work to get our framing box done. When you're doing your nails in on the side for this blocking, stay about an inch back from the edge. If you go any farther than that, we might have covered this in a previous framing video. If you go any farther than, if you go any closer than an inch to the edge, you run the risk of splitting this board. Those nails go with some pretty powerful force. We just did all that work to make this nice and neat and get it all set. It'd be a shame if we split our board and had to redo it again. You might even see the classic board throw on camera. So just a quick tip for you, when you're doing this, stay about an inch to an inch and a quarter back, and then just kind of fire it on an angle so that it has some good holding power into the board, but not steep enough of an angle that it shoots through the other side, but not too shallow so you still get some good holding power from the nail. Out of those 32 nails, one of them went through the edge by 1/4 of an inch. Got my lines marked out for the other section of the back bar. One little hiccup I did run into is if I were to do 16 inches on center, there's actually going to be a power outlet right in the way from the wall that we had done earlier. So no big deal. All I did was I just took my one stud, moved it over 2 inches. It's not that big of a deal. It's not structural load bearing where they have to be 16 inches on center. This will still give you plenty of support for what's going to go on top of it. Got our back bar in. Now what I want to do is I want to take those pieces of blocking that I put in, and I want to anchor the framing to the wall through the blocking through the studs that are behind the wall. A couple points of interest here. I have my laser level set up. I already have an established stud line from when I put the sheeting up, and it's nice where I have these electric boxes in because I know there's a stud right adjacent to there. One of the complications here is I have wires running through this wall in the back. So fortunately it's open on the back side, so I was able to go through and measure, and only this middle piece of blocking that I had to set lower is going to interfere with the wires. And I actually did that on purpose. I knew that the two higher ones in the back wouldn't, just from knowing the wiring layout from when I put the wires in. So I wanted these to be stronger. This way I know I can anchor, I can do some of those construction legs in here, and I'll just do some decking or framing screws in here. So what I did was I measured where the wire is, and I put a mark on my board, and I'm just going to stay a good 2 inches away from that, just to not be anywhere close to that wire. One of the things is I want this to be plumb. And I went ahead and measured this, and it's off, not by a lot, but by about 1/4 of an inch, a little more than I'm comfortable with. So is that going to show on frame? Yeah. So what I did was I put 2 screws in here, and I'm going to do the old pry trick with my hammer, where I go through and I suck this wall in closer to that one. I already know from measuring and tinkering with it off camera that once I do that and I get that flush into the wall, it's going to be good to go. It's going to be nice and plumb. So I'm just going to start some screws, I'm going to torque this over, drill them in, we'll be good to go.
to go. Really good to go. What I'm going to do here is I'm just going to take one of those headlock screws and just tack that guy in for a little extra support here. That is solid and not going anywhere. One last thing I did was I just took the framing nailer and I just fired some nails through this wall into this wall just to lock everything together in one unit. I have my back bar countertop pieces here. Pretty straightforward on this one. I just used some 3/4 inch hardwood plywood. This one is oak, I believe. And then just went ahead and did my measurements on how far I need them on each side and cut them on a 45. I did use my Carpenter's protractor here just to measure the corner, like so, and it gave me an even 45 degrees. These are a must if you're doing any type of trim work or crown molding or anything. They're great. They're like 15, 20 bucks on Amazon, and it will tell you what the angle is and it will tell you what your miter is supposed to be. So as I go through and put my boards on here, I don't have to really overthink this. They line up good. This one's 100% level. This one just needs a very, very minor shim to it. Maybe like a 32nd of an inch, not a whole heck of a lot. And then I'm just going to go ahead and use those construction screws and just tack this down here. I'll do some finishing work on the bottom edge in the corner here. I'll show you in a few minutes. But don't need to go crazy with the overbuilding on this like I did on the bar top. This is just going to have, for this point in time, just a carbon fiber wrap to it. So it's not going to have a whole lot of weight resting on here, and we're not going to have a whole lot of weight on the edge. This wall here will probably have a lot of weight with our backsplash coming down, but that's all compression forces down. I don't have anything that I'm really worried about teetering this off. Just using the construction screws and kind of a zigzag pattern on this is going to be more than sufficient to hold this in place. Most of what's going to be on here is going to be directly under the framing. I just have this small 3-inch overlap on there, and then even once we do that carbon fiber wrap on there and the epoxy, that's going to give it a lot more strength as well. Just going to take the oscillating tool, cut the shims off even. I looked at the camera and it was off. I don't know if I got that last segment or not. I just have a 2-inch strip of plywood here and the same stuff I used for the countertop, and I just drilled about 5 or 6 pilot holes down the center. Now I'm just going to take some Titebond wood glue and just do a little squiggle right down. You could also use construction adhesive for this, but you just need a little bit. Not worth opening a tube for. You don't have to go crazy on this, just enough to hold this underneath. That's just why I have just the sheetrock screws with the pre-drilled holes, and then just a little bit of wood glue. And I'll show you something else we're going to do on the end down here. Strengthen the joint between these two pieces. Adding that bottom strip I just did is going to do a couple things for us. First and foremost, it's meant to be decorative. It gives just that illusion of a thicker slab than what's actually there. It also gives us a little bit to wrap that carbon fiber around and kind of tuck it underneath. The other thing it does is down here, if you notice I didn't miter this end. I took it all the way over to the framing. So the end of the board is actually right about here, and that's where I put the screw in. Once I got everything lined up in place, I drilled another pilot hole right over here on the other piece of countertop. And I put another screw in there, and that's going to help lock these two sections in place because they're screwed in right next to each other on the framing, but over here is actually overhang, so they're kind of two separate pieces. I'm not too worried about it because it's strong plywood, but this way they're locked in together. It's going to be much stronger. Our next step here is just going to be to cut a curve on the corner of our back bar here. Is you're going to be going in and tending things back here and just walking through. You don't necessarily want a sharp corner on this. I went round and round on this if I want to do a round corner, no pun intended, or if I just wanted to 45 this off to match the other angles of the bar. And I stared at it for like way longer than I probably should have. And at the end of the day, I ended up wanting to go for the curve. When I used my square and just traced a 45 just to get an idea how that would look, I think it's going to look silly, right? Because it's going to end here and it's going to chop off a good portion of the counter. It's just going to look weird. Whereas the corner, I think, is going to make it look more finished. And also the corner is going to help if we end up doing that carbon fiber wrap around here. The corner is going to help drape that fabric better, and it's going to look like a neater finished corner. One of my hesitations with that was the main bar, we have that 45 cutout. So whenever you have that, you want to try and mirror that with your design concepts if you can. But again, just trying to apply the 45 concept to this. I think just shortening this corner here, it's just going to look weird. So look at the nice curve on here. You know, this way as people are walking into the bar, there's a better passageway. You're not catching your hip when you're going over here, tending to the AV cabinet or what will be bar shelves in the fridge. So talking about how to get the radius of our curve here, how to trace that curve out. You can certainly use a compass. I carry one in my kit. You know, you can trace out where you want the point to be and make a nice curve, and you can customize that down to like a millimeter. Probably not necessary in most cases. If you need it, you need it. But a lot of times, especially if you're doing construction, you're going to have things that have curves on them. All right, a lot of times you can use the radius of the back of a drill, different size rolls of painter tape, or in this case here, I have my cans of primer that we're going to use to prime the walls and ceiling, hopefully before not too long. So you can just line that right up on the edge, trace around that, and it gives you a perfect curve every time. And then we'll go ahead and cut this off, and then I'll do the same thing, and I'll cut a radius on that bottom trim piece, and then just do 2 legs that extend off, and we'll move on. So I just want to show you how we're going to go ahead and do our layout for that other curve for the underside strip. So I'm going to take my square here, and I have a 2-inch strip size. So I'm just going to go ahead and get some marker lines and just mark them out for 2 inches. So I got my paint can on here for the outer radius. Get that marked out. And now what I'll do is I'll just move in to my pencil marks for the inside radius. Trace that bad boy out. We're good to go. So this will be the curved piece that goes on that curve that we just cut out, and then that will carry on down for our straight pieces for the rest of the bar. I have my table saw set up outside by the truck. I just made these straight cuts on the table saw, and now I'll just use my jigsaw and finish up the curve cuts. We're good. I like the way this turned out. A little bit of bumps and imperfections here and there, but no big deal. We're just going to go ahead and take the sander and just get this nice and smooth. It doesn't have to be like finished paint, stain grade surface, because remember, it's either going to be an epoxy top or a carbon fiber top. This is just more so to give us shape and give us that illusion of depth to the counter. My next step here is to take my sander and just smooth out this corner a little bit, because we had that jigsaw cut. There is just a little bit of imperfection in the curve, so it's going to go ahead and smooth that out, and then we'll hit our top with the round over bit. Whenever I'm sanding plywood, even the hardwood, you know, it is like a composite of glue and different things, so you do have that airborne stuff that can have chemicals in it, so I always just wear a dust mask. And now I'm just going to take this just the rest of the way along the edge here, just to get a nice even edge. What I did was I just marked the center lines of where my framing goes, and I am just going to take a couple of these 3-inch framing screws and just drill down, just to tack this for one more element to have some more solidity in here. We talked before, this doesn't really need to withstand a tank. Most of it's going to be coming down and pushing down, but I do just want to have a little extra stability of anchoring this countertop into the framing, just in case plans change for the future. I'd rather have it stronger than it needs to be than weaker than it needs to be. My next step for this back bar top is to just go ahead and put a round over on the edge for that carbon fiber fabric to lay over. It'll just be a nice smooth transition. We want to give something, not just a square edge there. So for the front bar, I did a 1/8 inch. This will be the same concept, just a round over. But we're going to go a little bit bigger here and do a 3/16 on the back bar. For the front bar, we're just trying to get just a little bit of a round over to create a recession for the glue to sit in, just a little bit of a bead for it to form a seal between the edges of the bar, those rail surrounds, and when we get to the bar top, you'll see what I mean for that. For this, it's actually going to be a finished edge. So the final round over for this bar, or for this back bar top, is going to be what it looks like. So I want that to look really good and smooth. Or to make sure we're set up right, I just clamped in a scrap piece of plywood here, and I'm just going to go ahead and test that. Because for the front bar, if I screwed that up a little bit, if I went a little too high or a little too deep, no big deal, I can fix that, right? For this, it's going to be the final edge. So if I screw that up, I can fix it. Not that big of a deal. If I go too deep, I can just take some wood filler or some Bondo and just go ahead and put that in and sand it down to the contour. But I'd really rather not take an extra step and do that. I'd rather just test it on a scrap piece of wood. We got our height set up. We'll go ahead and get our round over on this. So hopefully you guys can see this with the 2x4 holding the wires here. I tried to move it out of the way and things started falling down, so I stopped. Over on this edge here, I can only get my router so far close to the wall. I do have a smaller battery operated trim router, but I'm using that for other projects here where I need more power. So I'm just doubling that because it's here and it's out. But either way, whether I use my smaller router or not, I still have a little bit of the square corner I couldn't get to because I can only get the bit so close to the wall. Same concept is true with the edge on this side as well as that actual main bar top. So what I'm going to do, I'm just going to take my detail sander here and just get those edges that I couldn't quite get to deep enough with the router and just match the contour of the rest of the curve here. And when you do that, it's a pretty simple process. Don't worry about having to match this exactly. Just go ahead and take your sander on a 45 and just get it down to that kind of radius and then just circle around to smooth out your top and bottom edges. It'll come out matching this almost perfect. One quick modification I want to make here is I do have on this lower lip here, when I cut out this curve radius, at one point the saw kicked in a little bit and dug in. And when I say saw kicked in and dug in, I think I just moved my hand the wrong way. But I have this little kind of dig in here on this bottom lip. Honestly, I don't think once I lay the carbon fiber over it, anyone would ever know or see it. But my worry is because it indents just a little bit, like not much, just like a 1/16 of an inch, but then I might have just a little bit of a dimple there when I put the fabric on and press it around with the epoxy. And I'll see if I can get a close-up on video and take a picture and kind of frame that in on this segment so you can see what I'm talking about up close. But what I'm going to do is I'm just going to take some Bondo and fill over this and then just sand it smooth just so everything is flush. Talk a lot about mistakes happen, you screw up, there's always a way to fix things. Some fixes are easier than others, but this is just one of those easy fixes, right? We had a little dig in with the saw, we'll just take some putty and fill into that and we'll be good to go. For this purpose here, I'm going to use the Bondo. You could probably use anything, just regular wood filler with the squeeze tube, even joint compound for that matter. But because I'm going on to bare wood here, I want to use the Bondo. That's just going to have a little bit of a better adherence to this. I don't have to worry about it falling off later. Once that epoxy carbon fiber combo is on there, it's not going to fall off anyway. That stuff cures very strong, but this way I just know I have a nice strong bond with my putty. So Bondo generally will come in a paint can, or a paint can type enclosure.
lot of separation there. Let's stir that. I don't need a whole lot. Generally the instructions are to put down a 3-inch circle. Definitely not going to do that because I don't need that much. I just need a little bit. Bondo is not quite like epoxy, this 2-part system, but you do have to use a hardener with this. So I'm just going to go ahead and agitate my tube here and mix this up. Bondo is not quite like epoxy, it's a 2-part system where you have equal parts A and B, but you do have to use that separate hardener. So when you buy the Bondo in the can, it should come with a separate tube of hardener. If you're using a lot of it, they do sell the hardener separate. They sell a bigger tube. As you see, well, you didn't see because you couldn't see inside the can, but that can of Bondo was about halfway gone, and I still had half of that tube left. So you do generally have enough. It's more so if you lose that little one or it hardens on you. And as you mix this, you'll feel it start to firm up. And it has a pretty short working time. You really kind of got to get on this fast once you get it mixed. Again, here it's not going to matter. I'm really just going to take my knife and swipe this over and smooth it out. But if you're doing a bigger project, if you're filling a bigger gap, you're going to want to use you're going to want to move quicker. And you notice I'm just kind of mixing this on a scrap board. That's all there is to it. I actually probably went overkill on that. I went over it a second time, didn't even need to. So we'll just let that dry and harden. The can says 15 minutes. We're going to give it a good 30 till it's sandable. And we'll just go ahead and sand over that and everything will be good to go. What I'm doing back here is, since I have the Bondo already mixed, I do have a slight gap here where this 45 comes together for the 2 counters in the back. Since I have my Bondo mixed, ready to go, I'm just going to use that to fill in this gap. I was going to caulk it at some point next time I had the tube of caulk out, but I've got the Bondo, that will work just the same. Part of it's because I use such a small amount, but like even now, just that short time this has been out, it's already starting to set on me. So like I said, this stuff does have a pretty quick set time. Once you get it mixed, you got to start working with it. And if something were to happen where it sets on you too quick, not a big deal. Just make a new batch. I will tell you, if you go a little heavy on the hardener, it does set up a lot quicker. It starts that chemical reaction to harden it, and it just speeds up the process. Just a quick pro tip. A lot of times if you notice, whenever you're trying to clean off a putty knife, whether it's doing something like Bondo or doing something if you're using a wood filler or even joint compound for that matter, once it starts to dry and set on there, it can be very difficult to get off. And a lot of times you end up throwing your knife out. As you can see, this one has seen a lot of use and has some dried stuff all over the knife. One thing I found works really well is just getting these acetone wipes. They're actually made for nail polish removal. They have a little pocket to put like your nail in there and get the nail polish off. But they're very similar to like alcohol prep pads. They come in boxes of like, I don't know, these are 100, 200. I just always have to stack them around. I have a stack in the truck, I have a couple stacks in my toolboxes. And you just tear it open and you get this acetone soaked pad. So it works really well for using and cleaning your tools off. Especially when you get, start to have the dried putty on there, that can be really tough to get off, and a lot of times people say forget it and throw the knife away. Well, that can get expensive if you use putty knives a lot. These also work very well when I'm using my spray foam gun. That's actually usually what I use these for, is whenever you use that spray foam gun, you have to use acetone to clean the nozzle off once you close it. Otherwise that spray foam will dry in there, and it will either make it so that your gun is permanently clogged, and you have to replace the tip, and now you got to take your gun apart, and usually it explodes.
Ask me how I know. Or you just have to get in there with a knife and clean things out because you're not getting a even bead anymore. Well, that's one of the reasons I went to just using these acetone wipes. I always kept a smaller bottle on the truck. There's very often times where I'll need acetone, but just a little bit, right? So every time I would need to do that, I'd have to get out the little tin, pop the top off of the screwdriver. It was just one more extra thing to carry in and out, right? One extra step. Well, I switched to using just these acetone wipes. It makes my life so much easier. I just always have them on hand, use it, clean whatever I need. Done, on to the next step.
Alright crew, that's it for this video. Thanks for watching, I hope you enjoyed. As always, if you could hit those like and subscribe buttons for me, help me keep that fresh content coming to you. And we'll see you in the next video. Once I get it posted, I will link it above. Until next time, take care.